Hi, I'm Kramer from Talent Home Solutions, and here we are for our introductory session on data structures for you to score quick. When we talk about data structures, what is data structure actually? We know what is data. Data is nothing but information. We know data types. How we want this data to be stored in the form of integers, in the form of float, characters, and so on. So data and data types are okay with us. But what's data structure? So data structure is nothing but a way to organize what your data is. You have to put this data in a format that will help us in easy, say, retrieval, or we want to sort this data, so it should make our life easy. So in definition wise, we can say data structure is nothing but organizing your data in the memory of your computer. So we know this, but how it's going to get implemented? To implement this data structure, we have to use ADTs, abstract data type. In this abstract data type, we specify what operations we want to perform, like we want to perform insertion, deletion, display of this data, or some other activities. So it specifies the operations, and finally it also should give us the computational complexity of using the data structure. We will have multiple abstract data types which will have different complexities. So depending on the situation, which one to use, we can decide based on this computational complexity. So a lot of theory. Let's understand the entire concept of data structures through examples. So we're going to talk about a few data structure examples here. First, very simple to go with is an array. We know what is an array. It's just a collection of similar data type. We can store, insert, retrieve or delete the information from an array. So we have created an array here. The second thing is a linked list. Now linked list is something which is dynamic, where we can create or give memory in a dynamic format. Definition wise, it's nothing but collection of nodes. It stores the information in form of a node, and each node will have your data plus a pointer to your next node. So here 5 has a pointer to 10, 10 has a pointer to 15, and so on. The last one points to the null. This is linked list. Both arrays and linked lists are linear format of storing your data. Let's talk about 4 more very important data structures. The first to start with is stack. Now when we talk about stack, some structure similar to this should appear in your mind, where the data is stored one above the other. When the data is stored one above the other, we have a format called as LIFO, last in first out. The data that goes in last will be retrieved first. So let's take an example here. I have created a small stack. This stack actually will be implemented using either an array or a linked list. For that matter, any of these data structures we are going to talk about is going to be built by using arrays or linked list. So in stack, this is stack wherein I have stored the information 5, about that 10, about that 15, and about that 20. The indicator in a stack is called as top. It is always pointing to the topmost element of this stack. If you want to insert any data into the stack, we'll put it above the top and just shift the top. And if you want to retrieve any element from the stack, we'll retrieve it from the top. So this is our stack data structure. Let's move to the second data structure. Important one is queues. So queue follows first in first out format. So the one who is in first will be out first. For example, we are standing in a queue for taking a ticket, say in a railway system. Now the person who is first in the queue will get his first chance to get the ticket. Here I have shown a queue where I have stored 10, 20, 30, 40, 50 this information into a queue. There are 2 indicators in queue. One is F and one is R. F is front and R is rear. So here if any other element wants to come into this queue, will always enter from the rear. And the retrieval process will always start from Then we'll come to, these are all linear data structures. Now we are going to talk about non-linear data structures, wherein the data is not in the form of horizontal or vertical format. So for that, we have the first data structure, which is trees. Tree stores the information in the form of a hierarchy. For example, you have a data of the CEO of the company, and then we have program managers under them, project managers under them, then supervisors, employees. So we follow a hierarchical data structure there. Such kind of information is in the form of parent and child. We use trees for such implementation. So here I have shown a tree in which I am storing a data, say 20, 10, 45, 15, 30, 50 and so on. The first node, these are all nodes, and the first node is called as a root. Root is the parent of all, and then we have the child, and this child is a parent of this particular child. Real world application, if you say there are different types of trees like BB plus trees or a binary search tree, these are very useful in while we are talking about computations, whether it be database programming or whether it be searching an element or sorting an element. So this was tree data structures. Now we talk about the second data structure, which is in a non-linear format. So the second data structure is called as graph, and graph is a set of vertices and edges. So you have certain vertices and they are connected through edges. You can have edges going anywhere in this graph. I have shown a very simple graph for that matter. The real world application, if you talk about it, can be used in electronic circuits where you have different resistors and capacitors and you want to know the flow. That is where we can compute those information. Or we can talk about whether you want to use any map wherein you want to find the distance or destination, the timing and all. Such kind of information can be calculated or computed in the form of graphs. So I have taken a very simple example wherein you are planning a tour starting from Mumbai, and you want to plan a north tour where you want to go to first Chandigarh, then Simla, Manali, Dharamshala and Amritsar. And when you are planning a tour, you have two things in your mind: your time and your cost, and you need to visit all this destination. Now, if such information should be very good to you and you can travel all your stuff in minimal time and minimal cost, that will be a best tool for you. So such kind of computation can be done using graphs. Thank you.